Hi, good morning to one and all. My name is M. Prakash. I am from Home Engineering College. We have done a final year project on IoT based automation for solar pipe mapping and environmental control in Sericulture shed under the guidance of Kodanam myself, head of the department, ECE. My teammates are M. Vamshi, Prem Kumar, Devar Prasad, Pawan Kumar, etc. This is my prototype model, which works on the IoT based, and we have used the components of solar panel of 6 volts and battery of 6 volts, and this is a voltage booster, and this is a voltage regulator, and this is a relay, mechanical switches and external load batteries, and we have used a microcontroller ESP8266 and with an enabled Wi-Fi module, and this is a 16x2 LCD display, and this is a BAT circuit which is used to control the flies by keeping an electric mesh, and this is a voltage sensor to measure the battery voltage, etc. And we use an exhaust fan for a cooling purpose, and we use an Peltier plate for heating purpose, and we use an bore motor to maintain water level, and we use an ultrasonic sensor to measure the distance in a canal, etc. The working principle of our prototype is to we majorly maintain the 4 parameters in sericulture shed. One is to control the pest and humidity and temperature. Humidity and temperature plays a major role in sericulture, so it is also a major parameter in sericulture shed. So pest and the sericulture crop is affecting due to 3 parameters only, that are temperature, humidity and pest, etc. When we control these 3 parameters, we get more yield in sericulture farming. Now I will explain the process, and we also can monitor our temperature and humidity in cloud also. Now we are connecting Wi-Fi to our device. We give a 5 volt supply to this node MCU. So our bore motor, when the distance is lesser than 5, our bore motor will turn on. Now distance is less, so bore motor is turned on. Here the bore motor is turned on. When the distance is 5, the bore motor will turn on. When the distance will get reduced, see, now distance is 3 lesser than 5, so the bore motor will turn off. It come to normal stage, and we use this voltage regulator to boost the voltage. We get power supply from this battery is 6 volts, so the relay is needed 12 volts. So this voltage booster will boost the 6 volts to 12 volts to give supply to the relays, and we use this voltage regulator to maintain a constant voltage which is connected through which needs to connect this node MCU and this LCD display and the voltage sensor and BAT, etc. And now the BAT, we on this BAT circuit to when flies enters to this, the BAT circuit will turn on like this. When the flies enter means it will get damaged. When the humans will touch, there is no effect. When the flies will only affect to this voltage. When the temperature goes around high, then the exhaust fan will on to maintain the temperature in sericulture shed. When the temperature gets reduced, then the Peltier plate supplies heat energy to maintain the constant temperature in solar in sericulture shed, etc. This is my prototype model, and we can also monitor through the cloud. And so first we see this temperature. Now present temperature is 33 degrees, and we can also monitor a voltage present in the battery, and we can also measure the water level, and the present temperature is 33 degrees. So we can analyze which is turned on and turned off in the sericulture shed, etc. And we can also monitor through a cloud. We can also monitor in mobile also, that is ThinkSpeak, and we can get messages through a device. It's get updated in seconds. We can it is also enabled with the notifications. The notifications will come to mobile. See, this is now present temperature is 34 degrees, and voltage is around 9, and the water level is etc. Then we can assume the motor is turned on, etc. This is my prototype model. Through IoT we monitor these 3 parameters, and we can control a pest and fly in the solar sericulture, in a smart sericulture shed.